Next is coplanar vector. As the name suggests, coplanar vectors are those which lie in one plane. So let vector x, vector y, vector z be three vectors in R cube. And if we can find alpha, beta, gamma belongs to real number system with at least one of them is non-zero such that alpha x, beta y, gamma z is equal to 0, then vector x, vector y, vector z are said to be coplanar vectors. Now if vector x, vector y and vector z are not coplanar, they are called non-coplanar vector or linear independent vectors. That is vectors which are not dependent upon each other. That is not the multiple of each other. Thus, if vector x, vector y and vector z are non-coplanar, vectors, then alpha vector x, beta vector y, gamma vector z is equal to vector 0 implies alpha is equal to 0, beta is equal to 0 and gamma is equal to 0, because if one of these become non-zero, then vector becomes coplanar. Now the problem is which is based on coplanar vector. Prove that -1, 0, -1, 0, -1, 1 and -1, 1, 0 are non-coplanar and that every x belongs to R here or x belongs to R cube can be written as vector x is equal to alpha times -1, 0, -1 plus beta times 0, -1, 1 plus gamma times -1, 1, 0 for some real number alpha, beta, gamma. Now from above it is clear that we have to check coplanar and express this in this form. Now we have to check whether the vectors are coplanar or not. So for this we have to check scalar triple product of these three vectors is equal to 0 or not equal to 0. So first of all we will find out the scalar triple product, that is vector x, vector y, vector z. It can be written as -1, 0, -1, 0, -1, 1 minus 1, 1, 0. Now we'll find the determinant of this. It becomes by first row minus 1, 0 minus 1, minus 0, 0 plus 1, minus 1, 0 minus 1. So we get minus minus plus 1, 0 plus this one 0, minus 1 into minus 1 is plus 1. That gives value 2. That determinant of this is not equal to 0. That is, scalar triple product of C vector is non-zero. That is, vector x, vector y and vector z are non-coplanar. And here you can see we take first vector as x, second vector as y and third vector as z as given in the question. Now we have to express vector x in the form of alpha, beta, gamma. So now let vector x with component x1, x2, x3 can be written as alpha times x vector, that is minus 1, 0, minus 1, beta times vector 0, minus 1, 1, plus gamma times minus 1, 1, 0. So we get x1, x2, x3 is equal to minus alpha 0 minus gamma plus 0 minus beta, beta plus minus gamma, gamma 0. So on addition of vector we get minus alpha minus gamma minus beta plus gamma, beta minus gamma. So on comparing we get minus alpha minus gamma is equal to x1 minus beta plus gamma is equal to x2 minus alpha plus beta is equal to x3. So on adding these two equations, we will get minus alpha minus beta is equal to x1 plus x2. And we have one equation minus alpha plus beta, and we have second equation minus alpha minus beta is equal to x1 plus x2 plus x3. So on solving these two equations, that is on adding, we will get, that is x1 plus x2 here. On adding, we will get minus 2 alpha is equal to x1 plus x2 plus x3, and alpha is equal to minus of x1 plus x2 plus x3 over 2. And on solving, we will get beta is equal to x3 minus x1 minus x2 over 2. So by substituting value of alpha or beta in this equation or in this equation, we will get the value of gamma as that is x2 plus x3 minus x1 over 2. Therefore, vector x is equal to alpha time, that is minus x1 plus x2 plus x3 over 2 times vector x minus 1, 0 minus 1 plus beta times, that is x3 minus x1 minus x2 over 2 times 0 minus 1, 1 plus gamma times x3 plus x2 minus x1 over 2 times minus 1, 1, 0. That was our requirement. Now the next problem is when is modulus value of x plus y is equal to modulus x plus modulus y, and verify your answer by giving one example of x and y. If vector x plus y modulus is equal to vector x plus vector y, then x and y are in same direction and also collinear. Now we have to give an example here, that is a requirement. Let x is 1, minus 1, 1, and vector y is 2, minus 2 and 2. So you can see vector x is equal to that is 1, minus 1 and 1. And if we multiply it by 2 and divide by 2, that is, it becomes 2 minus 2 and 2. That is, vector x is equal to k times vector y. As k is equal to half greater than 0, therefore vector x and y are in same direction. And also we have to find sum of vector x plus y, that becomes 3 minus 3 and 3. Now we will find modulus value of vector x and y. 3 is common out. We will take modulus value of 1, minus 1 and 1. It becomes 3 under root 1 square plus minus 1 square plus 1 square. So it gives 3 under root 3. Now we will find modulus value of vector x, that is under root 1 square plus minus 1 square plus 1 square, that is under root 3, and modulus value of vector y is 2 square plus minus 2 square again 4 plus 2 square again 4, that is under root 12. That is, modulus value of vector x is under root 3 and vector y is under root 12, that is 2 into 2 into 3, that is 2 under root 3. Now modulus value of x plus modulus value of y, that is under root 3 plus 2 under root 3, that is 3 under root 3, and this is the value of modulus value of x plus y. Hence, modulus value of x plus y is equal to modulus value of x plus modulus value of y. That means x and y are collinear, are in the same direction.